Hello, hello, hello. Uh, this video is going to be going over reactivity. This should hopefully be pretty quick. I am going to recommend that you have the reactivity notes pulled up or written down or something. I'm going to be making a couple edits to the notes that you have access to. This is the stuff. Okay, let's see. Hang on. I've got stuff up on my computer. This is the stuff you need. I was going to say try to take a screenshot of it, but I'm not sure how legible it really is. So yeah, this is the last page of the notes. We're not doing anything with atomic radius, but we are going to be doing quite a bit with reactivity. Now, the end goal here is that when you guys are given reactivity questions, I'm going to give you 3 or 4 elements, and you're going to have to tell me which one of them is either the most reactive or the least reactive. And I just realized that my AC was running, so hopefully you can hear me better now. So yeah, I'm going to give you, on the quiz, and on the test, you'll be given 3 or 4 elements. Well, 4. You're going to be given 4 every time. And you're going to have to either say which one is the most reactive or which one is the least reactive. So the worksheet that goes with this is worksheet 2.4, which you can find in Canvas. The key is not available in Canvas, but the worksheet itself is. For example, problem 1, I give you mercury, lead, polonium, and radon, and you have to tell me which one of those 4 is the most reactive, and then which one of those is the least. But that's what we're going to be kind of talking through. At the end of the day, these notes are basically just a list of things that you have to memorize. If you keep them straight, you'll be good to go. If you can't keep them straight, you are going to struggle mightily with this section. So you have been warned. So yeah, first and foremost, you will never, ever be asked to compare metals and non-metals. That's because you really can't. With one exception that we'll get to. Metals and non-metals react so differently that you can't really compare the reactivity of a non-metal to the reactivity of a metal. Okay, so you're only ever going to be comparing metals to other metals or non-metals to other non-metals. The exception of that being the noble gases, which again, we'll get to in a bit. Metalloids we'll also get to. So, yeah, let's get to it. Okay, so here's your periodic table. This is all 118 possible elements that you could have to identify or determine the reactivity of. The first one that we need to point out is francium, down here in the bottom corner. Francium is the most reactive metal. Okay, and we gauge the reactivity of the other metals based on it. In the opposite corner over here, we have francium. No, francium's the one we just did. We have fluorine. Fluorine is the most reactive non-metal. Okay, most reactive non-metal, most reactive metal. Okay, and now the noble gases. This column over here, group 18, 2 down to whatever radon is, 86, they are inert. So the noble gases will not react at all. So if I ask you to compare anything to a noble gas, the noble gas is less reactive. So you can compare a noble gas to anything. If I say which is more reactive, radon or technetium, the answer is the answer is going to be technetium because the noble gas is going to be inert. I could not find the pause button to try to stop that. My bad. Okay, so all the noble gases are inert. Okay, now coming back to this side, we have the alkali metals, which includes francium. Okay, the alkali metals, group 1, except for hydrogen. We're not doing anything with hydrogen, by the way. I'm not going to ever ask you about hydrogen. It's irrelevant in this conversation. All the alkali metals are more reactive than every other metal. Metal. The alkali metals are more reactive than every other metal. Not than every other element, every other metal. Okay? So all the other, I almost said it. All the other metals on the periodic table, here, down here, down here, even this other column right next to it, they're all less reactive than the alkali metals. Now, this next statement is not in the notes. So make a note of the timestamp because you're probably going to have to back this up again to hear this statement again. Okay, you need to add this to your notes. The alkaline earth metals are more reactive than every other metal except the alkali metals. Okay, they're the second most reactive metals family. Okay, so this column here, they're more reactive than all the other metals, but they are all six of these are less reactive than all six of these. So if I say what's more reactive, lithium or barium, the answer is lithium because lithium is in group 1 and barium is in group 2. The alkali metals are all more reactive than everything. The alkaline earth metals are more reactive than everything except the alkali metals. And again, by everything, I mean other metals. Okay, now, the halogens, fluorine, chlorine, bromine, and iodine. Okay, these four elements represent the halogens. They are the most reactive non-metals family. However, there is something really interesting that we can do with the non-metals that we can't really do with the metals. We can actually rank every single one of them because there's only 10. Once you exclude the noble gases, there are only 10 nonmetals on the periodic table: fluorine, chlorine, bromine, iodine, oxygen, sulfur, selenium, nitrogen, phosphorus, and carbon. Those are the only 10 nonmetals on the periodic table. And that order, the order that I just listed them in, is their order of reactivity. And you should write that down because you're going to need to know it. Okay, fluorine is the most reactive, carbon is the least reactive. Fluorine, chlorine, bromine, iodine. So iodine is the fourth most reactive nonmetal. After that, we have, I forgot it, oxygen. Yeah, oxygen. Then sulfur, selenium, which is not one we've done much with before, but it's there. Then nitrogen, phosphorus, and carbon. Okay, that list, or at least the pattern that I'm pointing out here, where I'm going down the column, okay, most, and as we go down it gets less. When we get to the bottom here, because that is a metalloid, not a nonmetal, when we get to the bottom with iodine, we jump back up to the next column, we work our way down, and we jump back up to the next, we come down, and then carbon's all that's left. Okay, going in that pattern, that's your reactivity for nonmetals. So you can figure those out pretty easily. Now, that brings us to generic overall statements. You now know the reactivity of all the nonmetals. So let's talk about the metalloids. The metalloids, the elements on the stair step here, are the least reactive elements. You can't compare them to each other. They all just have a super, super low reactivity. So you're never going to have to compare one metalloid to another metalloid, just like you'll never have to compare one noble gas to another noble gas. They are pretty well equally unreactive. That is, the noble gases are all unreactive completely, and the metalloids are all equally low. So I'm never going to ask you to compare them to each other. But you do need to know that if there is not a noble gas, but there is a metalloid, the metalloid is the lowest reactivity. If I ask you to compare carbon to boron, boron is the lower reactivity because boron is a metalloid and carbon is a nonmetal. If I ask you to compare silicon to aluminum, aluminum is a metal, silicon is a metalloid. Therefore, aluminum is more reactive because metalloids are low reactivity. But if I ask you to compare boron with helium, then boron is more reactive because the noble gases won't react at all. And I just realized I forgot to mention a term that you need to know. That term is inert. The noble gases are inert. That is INERT. And that means that they will not react. No matter what, the noble gases will not react. They're inert. And last but not least, let's talk about all those other metals on the periodic table. Okay, here is the rule of thumb when you are trying to determine the order of reactivity. The closer an element is to francium, because francium is the most reactive metal, the closer a metal is to francium, the more reactive it's going to be. The closer it is to the metalloids, the less reactive it's going to be. This only applies to metals. This does not work for nonmetals. Metals only. Okay, the closer it is to francium, the more reactive it is. So if I ask you to compare, I can't read this. Okay, technetium and molybdenum. Molybdenum is closer to francium, therefore molybdenum is more reactive than technetium. If I ask you to compare technetium to uranium, uranium is more reactive. What? Well, yeah, because all of the F block here goes in this gap between group 2 and group 3. Okay, all of these go here. So this whole section of the periodic table should be shifted that way by the width of the F block. So everything in the F block is more reactive than everything up here, metal-wise anyway. Okay? So reactivity increases as you approach francium and decreases as you approach the metalloids. Now, let's talk about that worksheet problem I mentioned. I'm going to go through that one specifically, and then I'm going to end this video because it's already kind of longer than I thought it would be. So the four elements are mercury, lead, polonium, and radon. Okay, those elements are here: radon, polonium, lead, and mercury. Okay, radon is a nonmetal, specifically a noble gas. Polonium is a metalloid, and lead and mercury are both metals. So, which one has to be the least reactive? Well, radon is a radon is a noble gas. So it is the least reactive because it has a reactivity of 0. You can't get less than that when you're talking about reactivity. So it's got the lowest. Okay, if I didn't give you radon, though, then what would it be? Well, polonium, because polonium is a metalloid. So that leaves for most reactive either mercury or lead. Well, mercury is closer to francium, so mercury is more reactive. And that's pretty much it. So yeah, I'm going to end this video here. That's reactivity.